take it after that point, that's to spur you on to go ahead and get it done, because that's the point where I'll grade it, right? And then you can take it again to up your grade on it. So why do I do that? You know, I've had people say, well, why do you let people take the quiz multiple times? I can make 100. Well, yeah, that's the point. It's a study tool rather than a testing tool, if that makes sense. Now, when you take the exam, you can't take it more than once. I've had people say, well, I thought I could take it more than once. No, you can't take the exam more than once, but you can take the quizzes. These are like your practice exams. Why are you not letting me shut that down? Let me switch the other one. All right. All right, we've been talking about different data types. And you can declare things as ints or floats, and there's a whole bunch of other different data types. You can let the compiler pick the data type for you by using the auto keyword. I'd recommend not doing that. You kind of really want to know what the data type is. But at some point, maybe that'll be useful to you. Maybe, you know, you want to get some data back from some function and you don't feel like looking up what that function returns exactly, then you could use the auto keyword. In which case, the data type is determined just by the value that you specify. If we're putting 100 into amount, then the compiler is going to go, oh, that better be an int, because that's a whole number without any decimal points. Here, oh, well, that one's got a decimal point, so we're going to make it a double. This one's a letter. It's got single quotes around it, so it's a letter, so we're going to make it a character. And this one's a long. How do we know it's a long? Because it's suffixed with an L, so it's going to make this a long. Now, in this particular implementation of the language, there's no difference between an int and a long, which is kind of crazy. We could kind of prove it to ourselves, though. I'd like to go ahead and do this. Go ahead and start Visual Studio. And today is going to be the last day that I type the boilerplate in. I'm going to just save it to a file and then copy it in every time in order to speed up. So I'm going to choose Visual C++, make an empty project. I'm going to call it June 11 _ CPP because I've already got a different one under that name for today. I'm going to open the Solution Explorer since I don't see it down on the side. View Solution Explorer. I'm going to right click on source file so I can do add new item. Choose the .cpp. Now down here I could just leave that source.cpp, but I feel like giving it a better name, June 11. Now I'm in it. I'm going to add my include, iostream.iostream. I also like including as a matter of course, string. And then do using namespace std. And like I said, after this, I'm going to just paste this into a notepad file so I don't have to do it over and over. All right, int main parentheses in parentheses system quote pause. Linux and Mac users don't bother. And then return 0. All right. So what I'm going to do is I'm going to highlight all this, copy it. I'm going to open Notepad, just from the search box down here, Notepad. I'm going to paste it in there. Come on. Oh, stop it. All right. I'm going to do File Save As, save it to my desktop, and call it Boilerplate CPP. For C++. And the next time I want to create a program, I'm just going to open that, copy and paste it. Okay, so I'm going to create some variables and then we're going to print their sizes. Why am I printing their sizes? Because that'll tell me how many bytes are used to allocate each piece of memory. So, I'm going to create an int called I. And I'm going to create a long called L. Notice I use a capital L just because lowercase l's kind of look like i's and they look like ones. And then I said I was going to make that a long. Sorry about that. Long L. I'm going to make this one a long L. Excuse me, 2 L's. Right, because I, L, and LL. While I'm at it, I'm going to make a float and call it F, and a double and call it D. Now I want to print out the size of each one, so I'm going to use some cout statements. So cout, arrow, arrow, quote, I, just so that I know what I'm doing, space, quote, arrow, arrow, size of, parentheses, I, in parentheses, arrow, arrow, ENDL. I'm going to copy and paste that so I don't have to type that in separately for each one of these 5 things. So now that I've typed it once, I'm going to highlight the whole line. Highlighting a whole line is easy if you're using Windows. You just move to the beginning of the line, you hold the Shift key down and hit the down cursor, boom, the whole thing's highlighted. Control C for paste, for copy. Control V like vehicle for paste. I want 5 lines because I'm printing out 5 different variables. And I'm just going to change them all to match the order here. I, L, LL, F, and D. Do the same thing over here. I, L, LL, F, and D. Now hopefully when I run it, it'll print out the variable name followed by the size of each one. And it seemed to do that. Make the font size easier to read. I wish it would keep this default between times when I run the program. Alright, so we see that an integer is a 4-byte data type. We see that a long is a 4-byte data type. Now if you've taken Java, that's kind of whack because a long is supposed to be able to hold larger numbers than an int. And in Java, an int is 4 bytes and a Java is 8 bytes. Excuse me, a long is an 8 byte. So if you want the equivalent of a Java long, you're going to use long in this language, which sounds silly, but yes, sir.
I have an error.
Sure, I'll be right there. And a float is a 4-byte data type, and a double is a double-wide floating point object. Okay. So the maximum size of an int is like 2 billion. That means that the maximum size of a long is also about 2 billion. I could be wrong. It might be 4 billion. I think it's 2 billion. The maximum size of a long, since it's twice as wide, it's got twice as many bytes, it can hold a number that's astronomically larger. I think it's a number followed by 19 zeros. A float can hold like up to 8 digits of precision, like 8.1234567, but then it's also got an exponent, and the exponent can go up to like 30, which is a pretty large number, right? You know, so if you typed in 8 E30, that'd be an 8 followed by 30 zeros. The maximum value a double can hold is far larger. It's got 16 digits of precision, so you could type in 8 dot, 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever, far more precise, and the exponent can get much larger, like 300. So if you typed in 8 exponent 300, that'd be an 8 followed by 300 zeros. So anytime you define a number in this language, as not having a decimal point, it defaults to being an int. Anytime you define a number as having a decimal point, it assumes it's a double. You can define your variables as being floats, but see, is going to assume that everything is a double if you type it in as a constant like that, as a literal constant. So for the purposes of this class, I may make all my floating point numbers doubles rather than floats, just because that's the default type. Now I can force a value to be some other type other than int. If I want to force something to be a long, and I don't mean force the variable here, because if I wanted to force that variable to be a long, I would just do that right. But the point that I'm talking about here are the literal constants, these numbers that I'm typing in here. I could type in 1 LL, and that forces that 1 to be treated as a long. So it would declare that x3 is a long as well. And if you want something to be forced to be a float rather than a double, you could do that. Auto x4 is equal to 1f. That means floating point. No, it doesn't. Capital F? No, it doesn't. Okay, forget that. So scope, the scope of the variable. It's a part of the program in which the variable can be accessed. A variable cannot be used before it is defined, and it cannot be used after it so-called falls out of scope. So what is scope? If I declare another pair of braces and I put a variable in here, like int Fred is equal to 3, and then down here I try to print out Fred, cout arrow Fred. I'm going to delete this line, so I'm not going to spend a lot of time putting ENDLs and stuff like that. It can't print that out because it's after the brace. The scope of this variable is only in the code block in which it is defined. If I wanted to print it out, I'd better define it up here, outside of the braces, or I'd better move this inside the brace. Those would be my two possible fixes. So by and large, that means that all of these variables are only available within the main function. And if I went down here and I defined another function, I need to get rid of that because it's saying that's an error. Fred is out of scope. So down here, if I try to create another function, that all it does is return 0. It doesn't do anything. But if I try to use any of these variables that I define, like L or capital L, that's an error because this was not defined within this block. It was defined within the other function up here. So these variables do not exist here. Well, what if I want a variable that exists for both places? You can use something called a global variable. And this isn't the best idea. It's kind of frowned upon. But it's a quick and dirty solution. If I took this variable and I moved it here, it's outside of all the code blocks, right? So it's valid everywhere in this source code file. It's available inside every function in it. So this is a global variable. It has global scope. This is not a global variable. It's a local variable, so it has local scope, meaning it's only available between the braces in which it is defined. The idea of a global variable just does not exist in Java, but you can kind of simulate it by making things class variables. The idea does exist in Python, but you may not have done it in Python. So a variable cannot be used before it is defined. If I do this, cout II, okay, fine, capitalize everything, I don't want you to. And then I define x, that's an error because x has not been defined yet. It's like you can't cook the egg until you get the egg. Arithmetic. Got to cover this in every class, but hopefully we don't have to spend too much time on it because I expect that you've already had this in 1113 or another class. Unary, binary, and ternary operators. There's only one unary operator. I'm going to completely skip it for now. Binary operators take two operands. The operator is the symbol. The operands are the values upon which the symbol acts upon. So here we're subtracting 7 from 13. Subtraction is the operand, and 13 and 7 are the operators. So why is it called binary? Because it's ones and zeros? No, it's called binary just because binary meaning 2, right? And then there's ternary. There's a ternary operator which has 3 components. And we'll talk about that. And the unary operator just is the minus sign in order to make something negative, right? You know, if you have an 8 but you want to make it negative, you stick that minus sign in front of it. And so they gave it the special name unary operator. Usually I don't think of the minus sign that makes a number negative as even being an operator at all, but strictly speaking it is. But I'm not going to ask you in my exams what a unary operator is. I definitely want you to know what the binary operators are. And there certainly will be a question or two over ternary operators when we give the examples for them. So the binary operators are all the math symbols. Multiply, divide, add, subtract. In Python you have an exponent operator, star star. We don't have one in this language. If you want to take something to the power of something else, you use a function, POW. Also that caret, that shift 6 that you may have used to indicate power of when you were typing, you know, in other math classes, that doesn't exist either. The only way to get exponents in this class is to use the POW function. But we have the other math symbols plus, you know, some strange ones. There's modulus. I hope you remember what modulus means. It means you divide by and you take the remainder. So 7 divided by 3, rounded down, I'll explain why I'm rounding down, is equal to 2. But 7 modulus 3, well, when we divided 3 into 7, we got 2 with a remainder of 1. Multiplication is easy. 7 times 3, 21. 7 minus 3 is 4. 7 plus 3 is 10. All of those are pretty intuitive. The only ones that aren't that intuitive are these two. And why do I say that? Because this will round down under certain circumstances. When will divide round down? Now in Python, we had a specific operator for rounding down. Not sure if every version of the class taught that, but if you use slash slash in Python, it means round down. If you use a single slash, it means don't round down. We don't have that choice in this language. What it does is it bases it on the operands. If both operands are integer types, it rounds down. So if you do 7 divided by 3, you're going to get 2. However, if one of them is a floating point type, if you do 7 divided by 3.0, it goes, oh, you're mixing apples and oranges. You're doing both ints and floats. It's okay for me not to round it down. And then 7 divided by 3 is like 2.3333, something like that. Well, this is important enough to actually make a point of. So the operators are symbols. Plus, minus, times, divide, modulus. And then we have other kinds of operators, but we'll get to those besides the math ones. And so A plus B, plus is the operator, and A, B are the operands. The division operator is special because its behavior differs based on what kind of data the operands are. If both operands of the dash operator, slash operator, are ints, it does integer division, meaning that the result is a whole number with anything else left over rounded down. It doesn't round it to the closest, it rounds down. If one or both operands of division are floats, floating point types, floats or doubles, it does floating point division. This is something you didn't have to worry about in Python. If you've taken Java, you are familiar with it. If you've taken Python, it didn't matter whether you were dividing an integer by an integer. 1 divided by 2 was equal to 0.5. In this language, 1 divided by 2, they're both integers. And so what's 1 divided by 2 rounded down? 0, which is totally counterintuitive, right? But that's the way it is. There's the order in which these operands are performed. Good old PEMDAS, except we don't have the exponent operator in this language. So if you're unfamiliar with what PEMDAS means, you have parentheses, that's the P. You have multiplication, you have division, and you have addition, and you have subtraction. Now, multiplication and division are actually of the same priority, same precedence. Addition and subtraction are of the same precedence. So PEMDAS doesn't mean you better go and do all your adds before you do any subtractions. It just means that these are of a lower level than the multiplication and division. And so if we have something like this, 1 plus 2 times 3, what is that equal to? Is it equal to 3 times 3? And the answer is no. Why? Because multiplication happens before addition, which you can tell there. So you would group it together when you were processing it in your head like that, because star happens before addition according to PEMDAS. Along with multiplication and division, modulus also is in the same. So, you know, I guess if we wanted to make a brand new acronym, it'd be PEMDAS. And there was some, people who said that they memorized that by doing, please excuse my dear Aunt Sally, PMDAS. Whatever. As long as you remember that parentheses are the highest precedence. I'm pretty sure I spelled that wrong. I'm just going to change it back to parents. Are the highest precedence, because if you group things like this, 1 plus 2 times 3, what does that equal to? 9. It's 9 because 1 plus 2, that happens first now. Even though PEMDAS says do multiplication before addition, parentheses happen even before that. You can control the precedence of your expressions, what things you want done first, by using parentheses. And there's nothing wrong with using parentheses to dictate it, even if you're just echoing what's going to happen anyways, right? If I have that, I could write it like this. It's not going to change the answer, but it certainly does make it more clear. Clarity helps. Clarity is a good thing. So there's nothing wrong with using parentheses to force things to operate, even if the way that you're forcing it is how it would behave anyways. So that's equal to 9, whereas what would this equal to? What happens first? The multiplication. So 2 times 3 is 6, plus 1, 7. So this is called order of operation, or precedence. This is just explaining about the division, integer division. 13 divided by 5 is 2. 13 divided by 5.0 is 2.6. Now, does that mean that the floating point one has to be on the bottom for floating point division to work? No. That would work just as well. That would work just as well. Just as long as one of them is floating point, it throws it into the other mode of working. No longer rounds down. Modulus. Modulus requires integers for both operands. And that's not true of all languages. I think if we popped open Python and did a modulus of two numbers with Python, but they were decimal, it wouldn't complain. The idea is weird in my head. But what if we do this? A is equal to 3
modulus 0.4. All right. Cool. I guess it makes sense. 0.4 can go into 3. How many times can it go in? It would go in, whatever, 7 times with 0.2 left over. And then there's a rounding error causing that to happen. So comments. Used to document parts of the program. Comments are just for us. The computer doesn't care whether our program has no comments or 1,000,000 comments. It compiles and runs just the same. What do you use comments for? You indicate the purpose of the program. You can describe the variables. You can explain complex sections of code. That's important. Indicating the purpose of the program is important. They skipped one, which is kind of maybe. Explaining your functions. Now, you don't have to explain main, but if you write another function and it's performing the interest calculation via the Graftenberg formula, I'm making that up, I don't know what that is, but you could put that in the comments. You might list the formula for it in the comments, and you could say what it returns. So I will give some examples of good commenting procedures as we go. On the other hand, when we're going along here, sometimes I don't make good comments, and sometimes I make way too many comments. But generally, there are two sorts of comments. There are the single line comments, and then there are the multi-line comments that can just go on and on. Now, some people like to make really fancy comment blocks like this. This is a multi-line comment. Great, that's hunky-dory. Or if you want to do it like this, this function calculates square root. Sure, you can do that. Whatever. In some degree, you can make things more difficult to read. Your goal is to make code that is easy to read and to comment the parts that are not easy to read or that you think that somebody needs to understand who's looking at it. In our simple programs here, where I'm saying x is equal to 3 and y is equal to 4 times x, just so I can show you how multiplication works, I'm not going to put a comment saying what x is and what y is. So I will use single letter variable names for short little things like that. But in general, single letter variable names are a bad idea. They don't convey enough information about it. You could call patient height h, right? Or you could call patient height pH. Both of those are kind of dumb variable names. If I saw pH, I would think that it was applying to like the pH balance, acid and base and stuff like that. The words patient height means something. It explains something. Or if I just called it inches, right? But that doesn't explain what I'm measuring in inches. So single line comments begin with a // So here's an example of documenting our variables. Int length. Well, what is that? It's a length in inches. It's a good idea to document it because what if it was length in centimeters? What if we treated it as though we're centimeters all the way down in the code, but it was just called length and we didn't document that it was centimeters? Well, that could be a problem. Then width in inches. Area, calculated area. Now you could give variable names that give so much information that the comments are almost unnecessary. Length in inches. There, we don't even need a comment. We know what that means. Width in inches. Area, we could do calculated area in inches. Am I going to do that up here? Not really very often. Why? Because if I type in variable names that are like 20 or 30 characters long and y'all are trying to catch up with me, we're going to have lots of problems. Certain things won't be shifted or there'll be typos or whatever, and it's not your fault. I would have the same problem typing this stuff in. So I tend towards shorter variable names. If you think that doing this makes your program clear, including both the units and the variable type, go for it. If you just want to use length and then say what it is in the comments, that's also cool. Calling it I because you think I is a cool term for inches, no, that's kind of lame. L, that's also lame. Doesn't mean that I won't do it, right? If I'm going to write a program that calculates height or asks for height and width and then multiplies those to get the area of the rectangle, instead of typing the whole word height, if I'm in a hurry and trying to get you all to type along with me, I might just call it H, right? Okay, and then there's multi-line comments. They can span multiple lines. Or you can make them on a single line. Back before the invention of C++, this is all you had. You didn't have this double slash business. The C programming language just used these. So yeah, that's how you commented, even on a single line. But we have the benefit now of using the slash slash instead. So named constants. Well, what is an unnamed constant? An unnamed constant is just also known as a literal. It's a number or string entered directly into the source code. Like this. If I do area is equal to 2 times 3.14159 times radius, like that, we have two unnamed constants in here. 2 and 3.14159. That's the wrong formula though. That's circumference. Anyways, so 2 and 3.14159 are unnamed constants. They don't have a name, right? It's just the number 2. It's literally typed in there, so they're also known as literals, or numeric literals. You'll see both terms in books. Our book may just use the term unnamed constant. But you can also have named constants. Named constants are when you give those guys a name. You declare them with a special keyword. Python does not have this idea. Java does, but it's the keyword final. I don't know why they didn't use const. To me, const is clear. But anyways, so if you want to make a constant for pi, const double pi equals 3.14159. Or you can just use the word auto there. I don't use auto, so I'm not going to be giving any more examples of using the auto keyword. I like knowing exactly what my data type is by how I define it. All right, and then when I print this out, or when I calculate it right, the circumference is equal to 2 times pi times radius. It's easy to read. Not only that, if there was an error in it, what if I did not type pi correctly? What if I accidentally repeated that? Well, that's wrong. What if I did it this way, though, and I copied and pasted this line 10 times in my program, right? I want to calculate 10 different circumferences. If there was a typo in it, and then I copied and I pasted it, that typo would appear 10 times in my program. And if I wanted to fix it, I'd have to find all 6 of them. If it's defined as a constant, then I only have to find it and fix it one time. You typically make things constants if they are things that are not going to change in the program. The value of pi should not change. It's a numeric constant. And the books will show like making a sales tax a constant. Great idea, but what if somebody needs to change the sales tax? Really, it probably ought to be stored somewhere external to the program, read from an INI file or a database or something like that, because eventually the sales tax will be raised. And if you gave somebody the executable, they wouldn't be able to change the code because it's literally encoded as as whatever the sales tax is. But any number that you know you don't want changed once it's declared, mark it as a const. Now in this case 2 is also an unnamed constant, but it's just part of a formula, right? I wouldn't bother making a name for the word 2. What would you call it? Just the word 2, TWO? Nah, if it's part of a mathematical formula, if it's not a value like 3.14159, I wouldn't bother making it a named constant. Another thing you might define like that is, I'm not going to even go there. So a named constant is a variable whose content cannot be changed during program execution. Tax rate is equal to 0.675. The number of states is 50. Well, until Puerto Rico is added. Typically, the rule of thumb is, and almost everybody does this, so you may as well do it too, that you name your constants in uppercase letters. And in programming languages like Python that don't have a way to dictate a constant, if you make it all caps, if you make your variable name all caps, other programmers know that you meant for that to be a constant and they don't reassign it. A gentleman's agreement. If you declare a variable in uppercase, it's going to be a constant. Even if you didn't use the word constant in front of it, it's supposed to be treated as a constant if it's all uppercase. And that's the end of chapter 2. Nope, there's one more thing. Programming style. Programming style is a visual organization of the source code using spaces, tabs, and blank lines. Unlike Python, you don't have to tab things over. You could type in everything without tabs. You don't have to add the blank lines, the white space between the sections of code, right? I wouldn't have to have that. And I've had a student or two saying they hate putting white space in their programs. So if they were going to write it, they would do that. I'm not going to count you off if you don't put, white space between the major blocks of the code. But it's like spaces between the paragraphs. If you're writing a book and there's a space between the paragraphs, it's easier for your eyes to zero in on the beginning of the new paragraph. And so I try to block my code off into paragraphs. Here I'm printing out a whole bunch of stuff. That's kind of one thing. So that's kind of one paragraph. Here I was demonstrating the auto keyword. And so that was kind of another conceptual paragraph in my mind. So I've just marked those off with some white space, with some character turns. The only opposite of that is my resolution, my screen real estate is limited compared to yours. And if I put a lot of white space in my code, then it's hard for me to get a lot of code on the screen for y'all to type along with. So I quite often put less white space than I would otherwise. Another thing that people do that's considered part of programming style is brace placement. Some people do that. Some people put it on the next line. The inventors of the C language liked it like that. So they wrote a bunch of books that way, and that became a standard. A lot of other people like doing it that way, so they do it that way. The Java developers, the people who invented Java, decided that that was the best way. Whatever. Just do it consistently. The reason I like it that way is that, it's easy to line up your braces when you eyeball them. To me, that's easier to line up. But there is an argument for doing it this way. And the argument is, it tells you where you might use a semicolon and might not. There are places where using a semicolon can break your code, like if statements. If I do this, if, I need to pick a variable that exists, x1. If x1 is greater than 0, print out something. See out, hello, whatever, who cares. If you go by the rule of, every line needs a semicolon, that breaks the code. Doesn't look like it breaks it. I guarantee that as I wander around and we're talking about if statements and while statements and stuff like that, there are going to be people who do that. Again, no shame. I've done it too. And you wonder why it doesn't work. What would really happen here is that it would print hello no matter what, regardless of whether this is true or not. If you had a while statement, while x1 is greater than 0, do some stuff. If you put a semicolon here, that makes it an infinite loop. Instantly the program is, I guess it's not instantly if it's infinite. Once it gets to that point, the program's not going to proceed any further. Why? Because of the misplaced semicolon. What does this really mean? What this means is do that. If x1 is greater than 0, do nothing. All right. And then it would print out hello, no matter what. What does this mean in reality? While x1 is greater than 0, do nothing. And since nothing would ever update that value, It would never stop doing nothing. Sounds ridiculous, but it's an infinite loop. It would stop. Okay, so why would brace placement help in these cases? If you put the brace on the same as the if, or the brace on the same as the while, it becomes real clear that you shouldn't do that, right? That just flat out looks wrong. So, there's an argument for doing it that way. If I followed that example, then folks putting semicolons after ifs and whiles would be far fewer, including myself, because I certainly have done it. But I'm addicted to the readability. To me, that's easier to read. Now that I've said all that, I'm just going to delete it. So programming style, putting white spaces in, tabs, comments, and stuff like that does not affect the syntax of the program. The program works the same way, but it affects the readability of the source code. And if you think about it, when you're writing code, you're going to write the code once, and then it's going to be read over and over and over by people maintaining it. If it's a part of a project, a big project, you know. So it's write once, read many. And so you're wasting a bunch of people's time if you don't comment your code. You know, taking your time to comment your code might take twice as long for you. But then if each person who reads it also has to stare at it twice as long and it gets read 1,000 times by people maintaining your code, you know, you've wasted 1,000 people's time. You add comments to make sure that your code is clear and to make sure that if you left the code and you came back to it 2 years later, you would understand what it does. And trust me, if you become a programmer, you'll run across code that you wrote years ago, and if you don't have any comments in it, it will blow your mind. I don't even remember writing that program, much less understand what I'm doing here. But if there are comments in there, you will. And then if you hand the project over to somebody else, they'll need the comments in order to understand it. You can go too far. You don't need to comment every single line of code. Just do it judiciously. All right, that is the end of Chapter 2. So you will want to do the Chapter 2 quiz. We're not going to take the time to do it right now. Why don't we go on and begin Chapter 3? Are there any questions? I don't say that often enough. Are we doing okay? Yes, sir.
I had one. Whenever I tried to download C++, it was coming up and it was like graying out include and define and stuff. And I think it had something to do with like the workload. I didn't know which workload to pick when I was installing it.
Well, that's kind of odd. But does it compile anyways, even though it's commented out?
There were programs that like we had done in class and I tried it and it like didn't work.
What I would do is I would rerun the install process and make sure that C++ is checked and see if that fixes it. Because when you're creating it, yeah, you can pick different libraries, so to speak, you know, of stuff to install in there. And maybe it just doesn't know what a C++ program is because we didn't install it that way. Did you do the Express version? The answer is probably no. But did you do the Express version or did you?
I did that one right before class today.
Well, why didn't it work? I don't know. Give it a shot and rerun the installer and see. Make sure that you selected that.
Okay. Thank you.
Sure. I think I'm using the last version of the textbook's PowerPoints. I should stuff the 9th edition's PowerPoints in here. Alright, so CIN. That's the standard input object. Did we already hit this slide? Maybe they mentioned it in the last chapter as well. Oh, we mentioned cout in the last chapter. It requires a header. If you use include IOStream, you get cout. If you don't use # include IOStream, you can't use it. We could prove that to ourselves by coming up here, commenting out include IOStream, and that breaks our program. Cout no longer works. Along with using IOStream, if you do this using namespace std, it makes typing cout easy. If I commented that out, if I didn't have that, then I would have to go, and I know I showed this, I would have to prefix all of these occurrences of cout with std : : whoopsie. I cannot type apparently, and every occurrence of ENDL as well, and every occurrence of the word CIN, and I think every occurrence of the word string. So you do save some time by using namespace std, and I'm sure I've already mentioned that it's considered bad taste to do that, because if you # include something and then you do using namespace std, you have no idea really what all it's bringing in. We don't know what a namespace is yet. We may give an example of that later today. All right, so I guess I'll leave those in there. And what does CIN do? It's a stream that reads from the keyboard into your variable. So you use the greater than rather than less than, the data is coming the other way. And C++ is probably the only language you'll ever see that does it this way. So information is retrieved with that, and it's stored in one or more variables. I wonder what would happen if you didn't store it anywhere, if you just did this. CIN, error. Is that an error? Yeah, okay. You have to read it into a variable. And it certainly has to be a variable. We could not read something into pi. We've already defined pi as a constant, right? So it can't change. And you can't do that, right? Because that's reading into a number. That doesn't make any sense. Some folks think that you could do this. We had a variable called Fred. Fred, arrow, CIN. Looks good, right? We have this CIN object. We want to store the results in Fred. No, that's not how it works. And that's kind of one of my beefs against these object input streams and object output streams. Of course, I'm not smart enough to have invented the C++ language, but when we were doing pseudocode and things like that in our other classes, it was always things like, X is equal to something. X is equal to input. Y is equal to read line if you were doing, Java. And in here, we're putting the variable last rather than first. But just get used to that. CIN and cout always are the first thing in the variable. So if you wanted to read something into Fred, you would do it that way. And here's an example of it. Program calculates the area of a rectangle. What is the length of the rectangle? Displaying a question is called prompting the user, or that's a prompt. Then we would let them type in the length. What is the width of the rectangle? We would let them type in the width. Then we would do a calculation, area is equal to length times width, and we would display the result. Cout the area of the rectangle is that, followed by a period, \n, return 0. So CIN does convert data to the type that matches the variable. Height is an int, so when we read it in, it should be read in as an int. Whereas if this was declared as a string, then when we read it in, it would be read in as a string, and that's very different than Python. In Python, you have the input statement. Everything you got back out of the input statement was always a string, and we had to convert it. Not in this language. This is a strongly typed language. You have to declare the type of every variable, even if you use the auto keyword and let it pick a type. It has a type, and it can use that type to determine how the data is being read from the keyboard and what it is being stored as. Why would I read in the height as a string? I probably wouldn't. I was just doing an example there. So displaying a prompt is a message that instructs the user to enter the data. You should always use cout to display a prompt before each CIN statement. So you use cout, you display how tall is the room, and then you use CIN. And I'm always contrasting this to Python so that the two people in here who haven't taken Python are going to be annoyed by me. But we had this ability. X is equal to input, how tall is the room, right? We had that ability. We don't have that ability here. If we're going to use cout and cin, they have to be on separate lines. We don't have the ability to do that at all. We can't mix them into one command. You could write your own function that would do that. That might be fun for giggles. Let's go back into Visual Studio and write an input function. I'm going to put it above main, because in this language, just like Python, you have to define your methods, your functions, before you can call them. Now there's a way around that, which we didn't have in Python. But for now, we're going to write a function called input. And it's going to input an int. So I'm going to call it int for int, input int, and it's going to take a string of a message to display, to ask for. So the first thing it's going to do is it's going to display that message. I could rename that to prompt. That's what the book was calling it, string prompt. And I'm not going to delete this one, so you may as well actually type it. So we would display the prompt. Cout error prompt. Now we need a variable to read into, which I probably should have declared up at the top, but you know, int return, and then cin. No, return is a really bad word to try to use as a variable name because it's a keyword. Result. Int space result. Cin error result. And then return result. Not that we've been defining functions yet in this class, but you probably have in other classes, so you probably have the idea down. Alrighty, so down here in my code, I could call that. I'm just going to tack it on to the very top of main. Eventually I'm going to comment it out so that we're not having to type in something every single time we run it. But let's do this. Int age is equal to input int. I did a capital I there, so if you did too. And then what is your age? Like that. So we've written a program, we wrote our own function because we were kind of missing the Python input statement. And that kind of simulates that. I don't necessarily recommend you do that. But you could make this a little bit better than what we've got here. You can make it loop until they give you valid input. Because sometimes a user will type in the wrong thing, right? They might not type in a number. They might type in letters. And we could rewrite this function so that it would reject anything like that and loop until the user gives us a good value. And that would be a very good thing to do because then whenever we call input, we would know that that was being handled correctly. Whereas if you're just doing cout and cin, you don't know what's going to happen when bad input is entered. We might even play with that. Okay, I'm going to run this. We wrote it. We may as well run it, see what it does. Make sure it works. What is your age? 20. Okay, yay, it worked. And if you wanted more input statements, you know, you just pass in different messages. Now guys, just because I demoed this doesn't mean that when you get any homework you have to write an input int function and do it that way. Just use cin and cout, unless you're feeling really ambitious. The problem of me uploading notes like this is that somebody will see that and they'll think that that is the right way of doing input, and then they'll try to make their code follow that example. You don't have to do that. I'm just giving you an example of writing a function to redefine how you want to do your input. Alrighty, gang. I don't know which of y'all who here gets migraines, but I'll raise my hand. I don't want to cut class short. Alright, so the cin object can be used to input more than one value at the same time, which is something that input couldn't do, the input command in Python. I'm going to comment out this call. mean, we demoed it, but all right. So I'm going to declare two variables, h for height, w for width. Now I am going to put a comment here, height and width. I'm not going to be that cheesy. Okay, and then we're going to see out, enter the height and width, then press return, press enter. \n, end quote. Since that's too much to fit on one line, I'm going to break it into two lines. You don't have to do this. Did you see what I did? I ended my quote, and then I used another arrow to begin my quote. Don't bother doing that. I just do that when it gets past one line. You can put it all in one line. Okay, and then CIN, H, W. Now let's calculate the area. Realistically, I shouldn't have made these ints, because what if the height was 2.5? But I've already done that, so I'm going to roll with it. So int area is equal to h times w. And then see out, the area is, end quote, area, arrow, beginning quote, period, \n. That's pretty much exactly their example in the book. So when I run it, it's asking for the height and the width. The height is 10, the width is 20, and it runs. Now notice that I put them on different lines of data. I didn't have to do that. The way the prompt was written makes me think that I need to do them on the same line, but that would work as well. 10 and 20, hit enter, and then it goes. The area is 200. What is happening is it's ignoring white space when it does its input. Like if I tab and I type in 10, and then I tab a whole bunch more and I type in 20. Same result. It ignored all that white space. What other kinds of white spaces are there besides tabs? Well, there's the space bar, but we would expect that to work the same. What happened here? All right, I guess. Enter the height and width. Okay, so right, la-di-da-di. Whoops, that's not right. Okay. 8 and 2, 16. Okay, but here's where it gets a little bit odder. You run it. What if you don't type in anything? It's waiting for me to type in some non-white space input to fill in the age. I haven't entered any data yet. So I'm going to type in a number, 10. Now it wants the second number. It's waiting to enter W, and I haven't. Finally, I give in with my little game here, and I enter 20, and it tells me that the area is 200. So when you type, it's filling in an input buffer. And the input buffer is just sitting there. It's full of all the characters you typed before you hit the enter key. And that's waiting to be read in. And then when the program hits an arrow, it reads the first so-called token out of the input buffer. And the token is just everything that's not part of a space or a tab. So if I type in space, 10, space, 20, the first token is the 10. It ignores all the white space. And that would get stored in there. And then the space, 20, the 20 is the second token, and it would be put in there. And where it gets weird, like I said, is that if you start hitting enter, all of that stuff is ignored until you give it a non-white space token, a non-white space value to fill in there. And that looks weird. When you're running it, you get to the point where the program is confusing you because you don't know what to type. All it is doing is displaying a blank space. Enter the height and width and press enter. What if I think I'm supposed to do them separately? So I type in 10. It just sits there blinking. I hit enter again. I hit enter again. I get frustrated. I hit escape. Now, maybe if I'm lucky, I realize I'm supposed to type in the other value. I don't do it that way very often, just for that reason. I rarely read in 2 values at the same time, but you can read in 4 values at the same time. You know, we could do arrow, arrow A, arrow, arrow B, arrow, arrow C, arrow, arrow D. You could string a whole bunch of them together, just like you can do C out, right? You could string in a whole bunch of different C outs into one, into one string. You can. Doesn't mean you have to. Doesn't mean that it's just how you're feeling it. So multiple values from the keyboard must be separated by spaces. That's a good point, because when I was talking about spaces, I said it was the stuff separated by white space. If I type in 1020, that looks like the height and the width, but not really. How's it going to know which one's the height and which one's the width? It doesn't. Now it's waiting for me to enter a second value. So when it says it has to be separated by spaces, that's not quite correct, because return also works. So you could say separated by white space. And remember that white space consists not only of the space bar, but of the tab key and hitting enter. Order is important. The first value entered goes into the first variable. If I type in 20 space 30, H is going to get 20. W is going to get 30. All right, let's lecture a little more and then take a break. Mathematical expressions.
These work the same way in every programming language that I know of. That's a procedural language. There are some weird languages. Area is equal to 2 times pi times radius. Right? Here's our variable, also known as the left-hand side. And here's our expression, the right-hand side. The right-hand side gets evaluated according to the laws of PEMDAS and filling in the variables with values and whatever. And when all that is done, it copies about the result of the expression into that variable declared here, defined here. Now the expression can be a bunch of different things. An expression could just be a 2, right? If we did area is equal to 2 semicolon, that is technically an expression. Typically the way our brain works is we think of an expression as something with plus signs and minus signs and multiplying, things like that, right? Not something that is just a single value. But they can be a combination of things, right? They can be variables combined with literals and constants, all separated by operators. That's typically how we think of an expression. So the order of operations, we talked about it. I didn't mention that the unary operator is the very first thing that happens even before parentheses. I'm not strictly sure if that's true. No, I would still put parentheses up at the top. I'm going to leave off unary operator as part of my order of PEMDAS, because to me the unary operator is part of the number, right? If you type in -3, you don't think that means 3 unary operator made negative. You just think of it as being -3. And then multiply and divide happen before addition and subtraction, just as we already talked. So we have this expression, 2 plus 2, 2 plus 2 times 2 minus 2. What does that equal? Well, what happens first in the whole expression? Which multiplication. So it multiplies that. 2 times 2 is 4, and so 2 plus 4 is 6, minus 2 takes it back down to 4. And here's our examples. Have to hide that off the side of the screen because those are the answers. Alrighty. What's that one? We know that multiplication happens first, so 2 times 4 is 8, plus 5 is 13. What about here? What happens first on that one? Division, so 10 divided by 2 is 5, minus 3 is 2. This is just like that other one we did. 12 times 2 happens first. Just like multiplication and division, modulus happens first. So what is 17 mod 2? It is 1, right? If you mod anything by 2, you're either going to get no remainder or 1 remainder, depending upon whether it is even or odd. And that's a very common test to check to see if a number is even or odd. You know, if x mod 2 equals 1, you know it was an odd number. But anyways, so 17 mod 2 is 1, because 2 divides evenly into 17 with 1 left over. No, not evenly. 2 divides into 17 with a remainder of 1. And so 4 plus 1 minus 1 is 4. And it's the same idea there.
Parentheses can be used to force the order of operation. If we didn't have parentheses there, we would get a different answer.
2 plus 2 times 2 minus 2. We already figured out that that's 4 because it's doing this first. But if we cluster this part of the expression with parentheses, then this happens first, not that. So 2 plus 2, that's 4. Times 2, that makes it 8. And then minus 2. Back down to 6. Or 2 plus, well, this is going to happen first. And what's 2 minus 2? 0. So 2 plus 2 times 0. That means 2 plus 0 is 2. And then if we cluster them both, what's 2 plus 2? 4. What's 2 minus 2? 0. So 4 times 0 is 0.
I should make a worksheet of this, make y'all do it. But why don't we take a break and get back together like at about 8:40. Coke break, bathroom break, whatever. If you're not back, wave your hand so I know. Everybody's here. Har, har, har. We got one missing already. Oh, sorry guys watching along at home. I didn't pause the recorder, so you've been sitting here waiting for 10 minutes. But I think we're all here. All right, we said 10 minutes. It's been 10. We're going to go back. All right, some more expressions. I think it'd be belaboring the point. Keep going. And yeah, we could keep trying to make it more and more complicated by throwing in more and more parentheses, but there's really no point. The one thing to note about writing these expressions is that if it makes it easier to solve by doing the calculation in 2 steps rather than 1, go ahead and do that. And like, what do I mean by that? What if you had something where you were trying to calculate the cost of paint? If paint, it costs $2 per cubic centimeter. It's incredibly expensive paint. And so, let's make this look more complicated. Trying to make this look really, really interesting. If paint costs, okay, forget it. And so then you figured it out. Price, if you have, what do you need to figure out the cubic centimeters? You would need to know the height of the cylinder and the radius of the cylinder. If you have those 2 pieces of information, you can figure out the volume. So price is equal to 2.85 times the height times pi r squared, 3.14159 times the power of the radius to the 2, and then say that we wanted to add on sales tax, whatever. You see what I'm going? Yeah, you could do all this in one calculation if you wanted to, but it's better to do it into 2 calculations. That'd be one way, but do it this way. Volume is equal to that, and then the price is equal to 2.85 times the volume, right? If you separate that into 2 statements, you're better off. One reason is just this looks simpler to understand, I hope. Especially if the price was calculated based on the results of its own formula, right? And what if there was a tax rate involved, and a sales commission or whatever. So doing this, breaking it up into several steps, makes it conceptually easier to understand. It also makes it easier to debug, right? You could print out the volume, then you could print out the price right there. Whereas if we do it in one fell swoop, we don't even know what the volume is. We calculated it on the fly. We multiplied it by, the cost per item, and then we got the final price. But if we were running that debugger through here, we could stop on this point, let it calculate that. We could hover our cursor over the volume, and the debugger would show us what the volume was. And then we could hit that step over button, and then hover our cursor over the price, and it would show us that. So there's a couple of reasons for breaking statements down like that. in general. If anything is too complicated to just instantly understand, and yeah, there are formulas with 5 or 6 or 7 different variables, and if that's just a formula, tough, that's just a formula. You might not want to break it down. But then again, if it makes sense for you to break it down, calculating the volume and then multiplying it, by a ratio to get the final price is a good thing to do. So algebraic expressions. Remember that in our textbooks, they won't use the multiplication symbol for some reason. They seem allergic to the multiply symbol. So you'll see area is equal to length width, or you'll see area is equal to height width. And we're supposed to go, oh, I know how to do that. I know what that really means. It means height multiplied times width. If I give you this formula and I tell you to use it in a program, you can't type in area equals HW. You have to type in area is equal to H times W. There's no exponent operator. So if the formula is area is equal to S squared, you got to use the POW function. Area is equal to POW, the power of S raised to the power of 2. You may need parentheses to maintain the order of operations. Right? If you have this expression, here's not how it would work. You can't do m is equal to y2 minus y1 divided by x2 minus x1. What's wrong with that?
We'll do y2, y1 and x2 first.
Yeah, you better do these first before you do the division. You have to calculate all of that first before you can divide, and you have to calculate this first before you can divide. There's really no way around it, unless you're going to do it in 2 separate steps. You could do that. You could do m1 is equal to that. You could do m2 is equal to that. And you could do m3 is equal to m1 divided by m2. Or whatever. Yeah. Really, you would just express it with the division sign. I mean, using parentheses. So the algebraic version and what it means. 6b. Well, we can't write 6b. The programming language won't know what that means. I suppose somebody could make a programming language that did, but none of the ones I've ever used do. Instead, since that means 6 times b, you have to put the multiply operator there. 312. Can't do that, so we do 3 asterisk 12, 3 times 12. 4xy. That doesn't work, so we put 4 times x times y. So this is going to go off into something slightly wonky, but we got to plow through it. When do you mix apples with oranges? Type conversion. Remember when we were talking about doing that integer division, and we had I is equal to, x divided by y, and the behavior changed based on what x and y's types were? So if x is an int, and if y is an int, then by the time we're done with this, let me just change that to a cout. What is it going to print? Well, x is 3, y is 2, but they're both ints, so it's going to round down, so it's going to print 1. Right. So this would print 1. What if one of them was a floating point type? Float x is equal to 3, int y is equal to 2, and then see out the same thing. Well, since one of the operands is floating point, it's going to do integer division. Excuse me, it's going to do floating point division, and it won't round down. Okay, great. We've already said that. Why are we talking about that? Because whenever you have a binary operator, the operands have to be of the same type. Now, when I say have to be, it doesn't mean we have to make them the same type, but the compiler sure is going to force them to be of the same type. So if they're both ints, great, no problem. But if one is an int and one is a float, the compiler substitutes code to convert the int to a float. So it can do a float divided by a float. As far as the compiler is concerned, the computer can only do mathematical operations on data of the same type. It can add an integer to an integer. It can add a float to a float. Back in the olden days, computers had floating point coprocessors, and floating point addition and multiply and stuff like that would get shunted off to that coprocessor and brought back in for the answer, whereas integer addition, multiply, and divide was done in the chip itself. Nowadays, it's all handled by the chip, but you can still be sure that underlying it all, integers and floating point numbers are stored in completely different formats in the bytes of the computer. And before you can do that plus or that minus or that divide, they have to be changed to compatible types. They have to both be integers, or they both have to both be floats. So if one is of one type and one is the other, one of them will get converted. In this case, the y will get converted to a float, so that we have a float divided by float. It'd be really dumb to convert the x to an int, right? Because then we're back down to doing an int divided by an int, and it would round down. And we didn't want it to round down in this case. We wanted it to do floating point math. So the lesser type, the int, would get converted to a float before it could do that. And it happens automatically. We don't even have to care about it. We can care if we so choose. If we didn't trust the compiler to do it, we could say, hey, I really want y to be a float, even though it's declared as an int. In Python, we did it that way. In this language, you have the alternative of doing it that way. That says take y, convert it to a float before you divide it. But we don't have to do that. The compiler does it for us. So we can just leave it like that and trust the compiler to handle it for us. And that happens not just for division. You know, division happens to be that odd bird where things happen differently based on whether they're multiplying or, whether they're both integers or not. But multiplying, they still have to be of the same type for the chip to know how to do it. Addition, they still have to be of the same type, and so the compiler rearranges the code inside it before it makes it executable to make sure that that happens.
Does it permanently modify it?
It doesn't modify your code, and it doesn't modify the value permanently. Very good question. After this is done, has y actually been changed? And the answer is no. It's still an int. It's just that on the fly it got converted for a float for the purposes of that calculation, but y really was untouched. That makes sense? Kind of like you handed somebody a photocopy of something in order for them to go run the errand, but you still had the original value. Excellent question. I haven't had anybody ask that. That's cool. So, apples with oranges, type conversion. Operands have to be performed between operands of the same type. Operations. If they're not of the same type, C++ will convert one to the other. This can impact the results of calculations. And there are rules for which way it converts. Ints get converted to floats, because you can conceivably lose data if you went the other way. We used whole numbers in our example, but what if it was this? Oh, I guess it was over in Notepad. What if I made x equal to 2.2 and y just flat out equal to 2? So 2.2 divided by 2 is 1.1, right? If x was being changed to an int for them both to be the same type, then it would have rounded this down to begin with, right? Because you can't have an int of 2.2, so it would round it, and we would have 2 divided by 2, which is 1. It would do the rounding again. So floats are never rounded to ints unless you absolutely insisted upon it. You could absolutely insist that this float, this x, I'm going to make that an f, right? Just to hammer in that that's a float. You could absolutely force this to be an int. And you could do that by casting it. You could say, I know it was a float, but I really want you to do integer division. And so turn it into an int before you do the math. And that would work. That would work. At that point, 2 divided by 2 is in fact 1. And so that would round it down. But if you're not going to do that, if you're going to let the compiler do it for you, then the less complex type, the int, will get converted to the more complex type. And there's a rule, there's a chain of conversions which are possible called data promoting. If the int is the less complicated type because it can't have floating point values, and the float is a more complicated type, then the ints will get converted to floats. But there's other mixtures too. You could have floats and you could have doubles, right? Doubles are double wide. They have more precision and they can hold larger values. So if this was a float and this was a double, they would still need to be changed to the same data format. It can't add a float to a double. They have to be of the same exact data type. So the lesser one, the float, why am I calling it lesser? It's less accurate, would be promoted to be of the greater type, the double, and then it would do this math on a double divided by a double. I can't wait for them to show an example of this actually mattering, though. Let's go find out. So the hierarchy of types. We said that an int can hold larger value, an unsigned int can hold a larger value than an int because it's got that extra bit. And that an unsigned long can hold a larger value than a long. So if you were doing math between an int and an unsigned int, then the int would get converted to an unsigned int before it did the rest of the math. It would. I wonder what would happen if that was a negative number. Let's find out. I'm going to go and stick this above the input questions because I hate having to answer questions before I get to do my new test. So, unsigned int UI is equal to 3. 4, whatever. I don't mind if the numbers divide evenly or not. Int I, hope I haven't already used that somewhere else, is equal to -4. Cout UI divided by I. Arrow, arrow, ENDL. I may need to put these things in parentheses in order to get them to work. Well, I forgot my arrow, arrow for one thing. Cout, arrow, arrow, UI divided by I. Arrow, arrow, ENDL. When it converts this int to an unsigned int, I wonder what it's going to do. 0. I was not expecting that. How about we make a temporary variable to hold our result? Unsigned int result is equal to UI divided by I. And then let's print out the result. Cout, arrow, arrow, result, arrow, arrow, ENDL. Alrighty. I'm not having a good explanation for what's going on yet. So what I'm going to do is this. I'm going to cast it. Just like I talked about. UI is equal to parentheses, unsigned int, end parentheses, I. What that means is take I and recast it in the form of an unsigned int and store it here. And then we can Cout UI. And boy howdy. All right. So when an int is converted to an unsigned int, if it's a negative number, I would just say that that's a problem. What's really happened is it's being converted to the 2's complement of the number. But we haven't really talked about 2's complement. So I'll just say that that's an error state. That's a data overrun happening there. So that really can have some effects, that data conversion thing. When we did, UI divided by I, we might have thought that -4 divided by -4 should have equaled -1. But due to data promotion and things like that, then it got converted into something that gave us a completely wrong answer. We kept getting 0. Alrighty, so ints will get promoted to longs. Longs will not be demoted to ints. Either one of these will get promoted to a float because a float is a bigger data type still. It can hold a much larger number than a long or an int, with the caveat that it's only got 8 digits of precision, and a long could have more than that, and then it would truncate those, but still it'll convert it. And then a double is larger than a float, so any of them can be converted to a double. And a long double, I guess, is even bigger than a double. Is that true? I'm not really sure I believe that it's true. I'm going to use the size of command to find out. Cout arrow arrow size of long double in parentheses arrow arrow ENDO. I'm getting sloppy. I'm not even putting print messages indicating what these variables are. All right. So a long double is no different than a double. Both of them are 8-byte values. I guess I'm going to go ahead and mention that down here. Int is a 4-byte int. A short is a 2-byte int. A long, goofily, is the same size as an int. And a long is an 8-byte int. As far as floating point are concerned, a float is a 4-byte. A double is a double wide, it's an 8-byte. And then I guess at a certain point they may modify the language so that a double byte is larger, but right now it's also 8 bytes. The ones that I really want you to remember are that one, that one, that one, and that one. So just know that long longs hold more data than ints, and doubles hold larger values or smaller values, right? Because if your exponents can be larger, then that could fit in a double and might not be able to fit into a float or something. And it's useful to remember that a short is smaller than an int. But I never have used a short when an int would suffice. Even if you're asking for a small value, like somebody's age, I don't see any advantage to storing that in a short as opposed to an int. It just adds visual complexity, and it's not like it makes it run any faster, and it's not like we're so limited on memory that we really need to worry about those 2 bytes on this 4 gigabyte machine. So type coercion is the automatic conversion of an operand to another data type. Promotion is converting to a higher data type, and all the examples I've given you are promotion. And then demotion is conversion to a lower data type. Now, I'm not sure when demotion happens. I hope they tell us. Oh, I can think of a time. This would be a syntax error in Java. If you did this, int x is equal to 3.4. Why is that a syntax error? Because you can't store 3.4 into a whole number. C and C++ go, hey, I'll do it. I'm just going to chop it down and make sure it's an int. That's demotion. Promotion happens when the values are being converted in order to match for an operand. Demotion can happen if you give it the wrong data type and it's just supposed to figure out how to fit it into the variable type, because it's not going to change x to a float in order to hold this. After this is done, int x will still be an int, which means that this data got truncated. In Java, that doesn't happen. The compiler will flag this as an error and it won't even let you go. It won't let you do it. The same, I believe, is true for C#. In Python, it doesn't matter because you don't declare your variables as having types. Alrighty, so there's other ones. A character, which is 1 byte long, and a short, which is 2 bytes long. Those are automatically promoted to ints. So we could put these into our list here. Bytes or chars are converted to shorts, which can be converted to ints, right? I'm going to go ahead and copy this and paste it into our notes. Promotion hierarchy. What if I spelled hierarchy correct? I have no idea. I before ye, except after 30 different exceptions. Okay, so when operating on values of different data types, the lower one is promoted to the data type of the higher one. When you use the equal sign, the type of the expression on the right will be converted to the type of the variable on the left, whether that involves promotion or demotion. Overflow and underflow. That occurs when assigning a variable that is too large or too small to be held in a variable. Have I shown you the picture of Pac-Man's screen? Nope. Okay. So one of the most famous bugs in classic arcade history. Well, that doesn't look like real Pac-Man. So you're sitting there and you're playing Pac-Man. It works all the way up to level 255. But once it gets past level 255, it draws that. Obviously, you can't play that game. You can't finish that level. You can't eat the right number of dots because the right number of dots doesn't exist on the screen. So, this is a bug caused by data overflow. Why is it overflow? Because the level in this game was stored in a single byte. And a single byte can hold, the largest value that a byte can hold is 255. So when it tried to add one to the level because he finished level 255, then it changed it to 256. Nope, 255 is the max, so it reset it back down to 0. Just like your old cars that had, odometers that were only 5 nines. And when they all rolled over because you drove 100,000 miles, too bad, it just said all zeros at that point. Same idea, that's data overflow. Let's prove to ourselves that that actually happens. Well, and to complete the story, the game has no idea how to draw level 0, right? The programmer who programmed it had no idea anybody would ever be that good. So they were not that good, so they never tested it out to that point. Let's write a program that demonstrates overflow. So again, I'm going to tack stuff on to the very top. I'm going to use a while loop since we've seen while loops before, but I'm going to use a character to store my data. What am I going to call this? Level. Why not? Level is equal to 1. And now I'm going to count another variable. I'm just going to call it C for counter. And it's going to go from 1, and I'm going to make it stop like at level 260, because that'll prove the point. While parentheses C is less than 260, do this. C out, arrow, arrow, level, space, end quote, arrow, arrow, and then the word level. But let's convert it to an int to make absolutely sure that we're seeing a number, not a character. So what did I do? I typed in int parentheses level. And then why don't I tack on an E and DL just to make it really clear. Then let's add 1 to level. Level plus plus. In Python we did plus equals 1. This one doesn't, that works in this language. I could do plus equals 1 just to make it look like Python. But I also have the option of doing plus plus, which means just add 1 to it. So when this runs, it should print out the levels 1 through 260. Actually, it'll print out 259 because I didn't do less than or equal to. Except we're going to have overrun. When it gets to 255, it's not going to be able to add 1 and get 260. Dude. That's not quite what I was expecting. Oh, I never increased C. I need to increase C as well, so C++. Because if our counter never increases, then the condition never becomes false. Kind of like if a player was so good they never stopped playing. All right, so anyways, now run it again, and you see what happens. It's not letting me scroll up. Where's my scroll bar? We see it do something a little bit different. I should have stored it in an unsigned short or something like that. But it started counting up. And then at a certain point, the data got larger than the data type would support. Maybe if we convert it to an unsigned int. Is uint a command that we can use? No. Okay, I'm going to rewrite this phrase right here so that it is converted to an unsigned int. So, parentheses, unsigned, in parentheses, or not in parentheses, int, now in parentheses, the word level. And I'm going to break my print statement up into 2 lines now because it's got longer than the end. Okay, so now it should demonstrate exactly what I wanted it to demonstrate to begin with, which is it'll get up to 255, but then reset back down to 0. Or not. Let's go look and see when that happens. Okay, forget it. I'm not getting it to display exactly. Just accept it. You saw what happened. It got past a certain point, and it was too large to be held in that data type, and so it messed up. That's called overflow, when the data gets too large to be converted into the data type that the variable is declared in. So it tries to, quote, wrap around. Well, I won't say it tries. What happens is it just gets truncated to fit into the available space. And sometimes that truncation results in it being 0. What I was hoping was to see 255 turn into 0 at that truncation, but it's being treated as a signed value, and we saw a flip between positive and negative, and it just didn't work the way I was hoping. So different systems may do different things. A system might display a warning or an error message. It might stop the program. It might continue executing using the incorrect value. That's what Pac-Man did. It didn't care that it was an incorrect value. It just kept running. Now that that error is known, people have gone in and they've hacked the ROMs, right? You know, you can dump ROM files to, you know, a file that you can put on your computer or whatever, and you can run emulators so that you can play these classic games, or you can play Nintendo games or stuff like that on your PlayStations, on your computers. Play Nintendo or Sega early PlayStation games on your computers. You probably have, some of y'all probably done that. So people have taken those ROM files and they've spliced in a fix, right? So that if it gets to 0, it bumps it up to 1, and that way you could play it forever, you know, which would probably not be good for you, but you could. Typecasting. That's where, like, Leonard Nimoy played Spock, and then he never got another job because people always thought he was Spock. Nope, that's not what typecasting is. Typecasting was when you do manual data type conversion rather than coercing, which is where it happens automatically. Here's the syntax that the book is showing you. It's like the super coolest syntax for converting something from one to the other. This says, take the answer of this, or take whatever's over here and cast it to be a double. Just a so-called static cast. But it's not the only way that you can cast things. There are several different casting syntaxes. Oh, and you aren't going to show me? I'll show you. Because I've already, oh, here they go. You can do it like that. I just demonstrated that form. You can do it like that. I just demonstrated that form. It says both are still supported in C++, but static cast is preferred. Honestly, I don't remember why. We could Google why is static cast preferred. Why use static cast? Let's see what Stack Overflow says. I've been writing C++ for 20 years, and I've never understood why we should use static cast. Alright, so here's the answer. Static cast is used for cases where you want to reverse an implicit conversion with a few restrictions and additions. Static cast performs no runtime checks. This should be useful if you know that they were okay. That's not explaining the difference between a static cast and the other style casting. It's explaining the difference between a static cast and a dynamics cast. Whatever. In my class, I don't care which one of these you use. You're honestly not going to probably have to do any casting at all, but of course it's going to show up on a quiz and an exam question. So if I ask you how to do a conversion, a casting, any of these syntaxes is the correct answer. I don't care if you use static cast, or if you do the Python style, or if you do the old C style, which is that. May as well make a note of that. Casting. X equals INTY, that works. Converts Y to an int to be stored in X. Or X is equal to parentheses, INT in parentheses Y. Does the same thing. And X is equal to static underscore cast, angle brace INT. Let's make the syntax as hard as possible. End brace, parentheses Y. Does the same thing. If I felt like being Python-y, I would do it like this. But my first language I learned was C, so I do it like this. Note that that doesn't do conversion from strings to numbers. I can't do this. And you could in Python. That would take the value 100 and convert it to 100 in int to be stored in X. Type conversion is different than turning a string into a number. C has no idea what that 100 is. You can write a function, of course, that will convert a string to a number, but you can't just do it by casting. So multiple assignments and combined assignments. If you want to, you can do this. X is equal to Y is equal to Z is equal to 5. So what happens? 5 gets copied into Z, and then it gets copied into Y, and it gets copied into X. You have to do it that way? No, you could say X is equal to 5, Y is equal to 5, Z is equal to 5. Can I think of any time when I would do that? The only time I've ever done that is when I want to set them all to 0, right? It's quicker to say X is equal to Y is equal to Z is equal to 0. Resetting everything to 0, great. If I had to reset everything to another value, sure, I might use that syntax. You can also, declare multiple variables on the same line. So you could do int X is equal to 5, comma, Y is equal to 5, comma, Z is equal to 5. Or you could do int X, comma, Y, comma, Z, and then do X is equal to Y is equal to Z. Or you could do this, int X, int Y, int Z, and you could assign them all, equal to 5 as you did that. This is my preferred way. I'd rather do it that way. The only reason I would do something like that is if I was trying to put, more code on the screen for y'all to type in without having to scroll up and down. This is my preferred way. I guess this would be, I don't know. I don't know what I would even say my second preferred way is. By far, I would do it this way. But you can. Alrighty, so combined assignment. Sum is equal to sum plus 1, adds 1. This expression is handled, and then the result is copied into that variable. So when it's done, sum has been incremented by 1. And why we need this many examples, I don't know. But x is equal to x times 10, what does it do? 10 times x, stored back into x. X is equal to x minus 3. X minus 3 is calculated and stored into x. So by your result is that x is equal, the value subtracted from it. There are shorter forms for doing that. If you want to add 1 to x, you could do sum is equal to sum plus x. Or you could do sum, if you want to add 1 to sum and store back into sum, you can do sum is equal to sum plus 1. Or you could do sum plus equals 1. That's how you did it in Python most likely. C also gives you the increment operator, like that. And I prefer that in languages that support that. Java, C, C++, C#. But along with plus equals, you have minus equals, times equals, and so on. So if you had this expression, y is equal to y times 10, you could do y times equals 10. If you had z is equal to z divided by 20, you could do z divide equals 20. If you have d is equal to d modulus 2, you could do d modulus equals 2. Those all mean the same, right? Both of these mean the same thing. If you're doing 1 is a special thing. Adding and subtracting 1 happens so often in programming that they made its own separate symbol for it in this language. So you could do, C is equal to C plus 1. You could do C plus equals 1. Or you could do C plus plus. Thus the name of the language. All right, I feel the energy level in the class sinking. I feel my incipient migraine becoming less incipient and more active. Alrighty, so formatting output. I'm going to skip this part entirely. And I'm hoping we'll get to something a little bit more interesting. What do you do with formatted output is like if you want to specify the number of decimal places. You want to print pi, but you only want to print it to 3 decimal places. There's a way to do that. If you want to line things up in columns, and so you want to format all the numbers to be equal to 5 spaces, you can use these stream manipulators in order to do that. But to me, it's a different concept than what we've been talking about. It's output rather than calculations, and so I want to get something a little bit different. Working with characters and string objects. Using CIN with arrow can cause problems, and the problem is it passes over and ignores any leading white space. Not only any leading white space, but what if you ask somebody to type in their name and they type in one word, John? Great. What if they type in 2 names? John Williams. What if they type in 3 names? John Q. Williams. Well, if we program it with arrow, it's not really going to work. I'll show you what I mean. Let's do this. Cout. Nope, I'm in the wrong place. Go to the top of main, as usual. Let's declare a string called name. And let's declare an int called weight. And we're going to read in something into the name variable and into the weight variable. So we're going to display a prompt. Please enter name. And then CIN greater than name. Now do cout arrow. Please enter weight in pounds, LBS, \n, end quote, semicolon, and CIN into weight. Now we're just going to print those 2 values out. Cout arrow quote weight equals end quote arrow weight arrow ENDL. And then cout arrow name equals in space, space end quote arrow name arrow ENDL. And if you're using Windows, go for this. Do a system pause right there, just so that we're not even running the program any further. Now run that and type in a single word as a name. Watch its output. But then cancel it and run it again and enter 2 names, like a first name and a last name. So if you enter Donald as the name, it's going to work. But if you enter Donald Trump as the name, it's not going to work. So if I run it, please enter name. Donald. Please enter weight, 180. It worked. Weight is equal to 180, name is equal to Donald. I'm going to close that program and I'm going to run it in and I'm going to enter a first and a last name. Please enter name, Donald Trump. And check it out. It said please enter weight in pounds. It didn't even give me a chance to type anything, and then the weight is this completely wrong value. What's happening? Well, I told you about how it tokenizes it so that each piece of input is everything that's separated by the white spaces. And so when we type in the name, Donald Trump, Donald gets stored in name, and then it tries to store Trump into this variable called weight. Well, Trump is a word. It's not a number. And so it's completely messed up. What if we wanted to allow first names or last names? Instead, you use getLine. So to work around this problem, you can use a C++ function called getLine. Oh, and of course they don't give us an answer. And okay, fine. Here we go. So where it asks for our name, instead of using CIN arrow name, we're going to change that statement. And I predict that we're going to get another problem after we do this, but at least this part's going to work. CIN dot getLine parentheses name. I seem to have a dot there as an error. I better go back and look at the slide to see what I've done wrong. Oh, excuse me. GetLine, I had it completely wrong. Sorry, erase all that. GetLine parentheses CIN dot name. That means reading from CIN, get the value and store it in a name. But what it does is it waits for you to type in the whole thing and hit enter. You Java guys might remember that there's a next line command which reads in an entire line full of data. Whereas if you just call .next, you just get one token, just like this CIN stuff. All right, I'm going to run it and see what happens. All right, please enter name. I'm going to give it a first and a last name. Please enter weight in pounds. It's actually working. Quite often when you start mixing getLine with just using arrows, it gets to the point where it's behaving very poorly, where it starts skipping input. But we didn't run into that case here. And it worked, right? Because it printed out our full name. It printed out Donald Space Trump. So that fixed the error of whether somebody was going to enter one name for their name or two names. So you can do that. If you want to read in an entire line of data rather than just one piece of it that has been tokenized by the white space, you use getLine. What does it do with spaces at the beginning? Let's find out. We've seen that CIN arrow skips all the spaces at the beginning. It did not skip the spaces. So getLine does not skip leading white space. It's not doing any tokenization of it at all, except it's breaking it off at the enter key. But the rest of it, all the rest of it is being stored in the variable specified by getLine. Can I cover this page up, or I haven't wandered around and make sure y'all are doing okay. Please let me know if when I'm going, if I go too fast or you hit an error. Everybody okay? Good deal. I've had people who were too shy to stop me halfway through. Right. Don't be shy. There's also one called .get, which is useful for reading a single character. And here's our example of it. You declare a character. You hit say strike any key to continue. And then you do CIN arrow CH. The problem with that is that it will skip over any blanks or any tabs or the carriage return. So instead you can use .get, which will read the next character entered even white space. And if we were cool, we would be doing that in place of using system pause. We could replace that. We could define our character. I think I've already got something called ch, so this is probably going to give us a problem. And then I could do cin.get ch. I would want to preface it with the line hit enter to continue. So see out arrow, enter to continue, or hit any key. You know what the joke is. Yeah, I can't find the any key. All right, hit any key to continue. And let's see if that works the same way the pause statement did. I have deleted the, no I haven't. I'm going to remove the pause statement out. Please enter name, Bob. Please enter weight, 180. And it didn't wait for us. I'm not real sold on using .get in order to implement a pause function. But system pause is a really tacky way of doing it because it is very Windows specific. So I ought to learn how to do this properly. I'm going to throw this up at the top of the code and see if that makes a difference. I'm going to move this up to the very top, even above please enter name. Now it's working. So what you would have to do realistically to get this to work is you have to flush the input buffer so that nothing was left in the input buffer, and then you could say hit any key to continue. You could sit there and wait. And does that sound complicated? Well, it's not complicated, but it worked for you? Okay, so I don't know what I was doing wrong. Did you enter one name or two? Okay. Okay. I believe you, but it's weird.
Still executing code. It was doing that please enter weight and it hadn't reached that section yet.
Oh, that would be why. That would be why. Okay. Okay. So no, it's not waiting for me. The problem is that there's something left in the buffer, even though there shouldn't be. And so it's triggering that automatically. I don't remember if the book tells us how to get around that or not. Yeah. To skip over unneeded characters that are still in the keyboard buffer, use cin.ignore. So cin.ignore would just skip one character. But maybe that's enough. So above our .get, let's put cin.ignore. So above here, hit any key to continue, define our character, cin.ignore, like that. Please enter name, Bob, 112. And that worked. If it needed to skip more than one character, you can put in a number here to specify how many characters you wanted to skip. And it's conceivable that you would want it to be a very large number of characters. So you can put in a huge number there. But in this case, that seemed to work. So if and we wanted to be correct, we could put this as our replacement for pause. Now you can see it's longer, and that's why I've been skipping pause. But I ought to show you this method and convince you to do it even while I don't. I'm just going to put in our comments, replace system pause with this. But the good news is that if you're using an operating system other than Windows, you're not going to be using pause anyways. If you're writing this stuff to be run from the command prompt and you're not running it from the debugger, then it'll just go back to the terminal when it's done, just like CMD, right? If I run a program here, I don't need it to say, press any key to continue. It just ran the program and then it came back and it's waiting for me to do the next thing. And the only time we need these pauses really is when we're running in the debugger inside of Windows. So even though we stick it in every single one of our programs, think long and hard before you do it in anything else. If it's a non-Windows system, it's not going to work. If it's designed to be run from the command prompt, then it's not necessary. If it's a Windows-based application that displays Windows rather than, typing in a console, you absolutely don't need it. So string, member functions, and operators. In my mind, we're practically going into another chapter here. We were talking about a whole bunch of stuff with numbers, and now we're talking about strings. But that's okay. If you declare a string, how do you declare a string? You better # include string, and you also better do using namespace std. Otherwise, you would have to prefix it with std : string in order to get one to work. But anyways, the way this works is it creates a variable of a data type called string. It's a different data type than an int and a float. Those are primitive data types. A string is actually a class in this language, which means not only does it have data, but it has functions attached to it. One of the functions attached to it is length. You feel like getting the size of the string, go for it. If you want to add two strings together, well, you're not really adding, you're concatenating, you're joining, you're appending. So, greeting2 is equal to greeting1 plus name. That would take name1, append it to greeting1, and store it in the greeting2. You can also do just plus equals. Greeting1 plus equals name2. This would tack on name2 to the end of your greeting. That's called concatenation. So the same operator means two different things based on its context. If there's a string, it does concatenation. If there's numbers here, it does addition. All right, now we're getting back to what I think should be in the chapter, math library functions. If you include CMath, you get cool functions. You wouldn't want to have to write your own sine, cosine, or tangent functions. Sure, you could do that. You wouldn't want to write your own square root function. You could cheat by calling the power function, POW, because if you're going to square something, you do POW to the 2, that's squaring something. But if you want to take the square root, you take that number to the 1/2, and that generates the square root. But that's stupid. Why would you want to do that if you have a nice square root function given to you? Or if you want to calculate the log or the absolute value of something. So,
You can do that with power function, you can have fractional exponents.
power should actually take fractional exponents. Let's find out. Very good question. Back up to the top. Double value is equal to POW 3.1 to the power of 0.5. And then I'm just going to see out value ENDL. That should calculate the square root of 3.1. Yeah, I trust that that's accurate. Floating point numbers introduce the concept of rounding errors because they're not precise. Like, an int is a whole number. 3 is an exact 3. 4 is an exact 4. But floating point numbers are approximations because they're stored as binary rather than decimal numbers. So 3.1 is some binary approximation of 3.1, and 0.5 is a binary approximation of that. So you can get rounding errors where what you thought was really equal to 4 is equal to 3.999999999. Let's see if we can prove that to be the case in this example. If we take that value and we square it, it should be exactly equal to 3.1. But let's see if it is. C out, arrow, arrow, POW, value, comma 2, right? Because we just took the square root of it. And now we're going to square it again and see if it's the same number. And they are going to display it as the same, honestly. Well, that was dumb. I'm going to rewrite this code a little bit to prove my point. Sorry, guys. I'm going to declare a variable called original. Double space orig is equal to 3.1. And then the next line is going to say double value is equal to POW orig. Now we're going to square that number. Value equals POW value to the power of 2. So it should be back to itself at that point. But let's find out if there's any difference or not. Double diff is equal to the orig minus the value. And let's print that difference out and see if it's exactly 0. C out, arrow, arrow, quote, diff equals end space, or space end quote, arrow, arrow, diff, arrow, E and D out. If we didn't lose any data, if there's no rounding errors, then the difference between the two is going to be 0. But it probably will be. The square root of 3.1, and then when we square it back, I'm predicting that there will be a small difference between the answers. I could be wrong. Okay, fine, I'm wrong. At some point, I'll be able to show you a rounding error. I should have had that prepped in my mind, so never mind. I guess this is demonstrating that we could do the square root that way. But you can import the CMath library and get other square root functions, like absolute value. You could calculate the absolute value of something. What's absolute value mean? It's drops a negative sign if there is a negative sign. The absolute value of negative 10 is 10. You could write an if statement that did that, right? If x is less than 0, x is equal to 0 minus x. You can convert a number that way, but it's nice to have an ABS function. And ABS is built into Python and a bunch of other languages, but it's part of the CMath library in this thing.
So if I try and do like power original 3 divided by 5, it's giving me 1 every time I do that. Can you not do that? Like have an actual fraction?
When you're doing the 3 divided by 5, it's going to be integer math and it's rounding that down to 0. So if you did 3.0 divided by 5, it's going to be a lot faster. Yeah. Very good point. That's an example of when this type coercion, or when integer division is messing you up when you're not expecting it. Another example of that is if the formula shows like 1/2 times something. If the expression was, value is equal to 1/2 times, 10. You'd really like for that to be 5, right? It's going to be 0. Well, I didn't even print it out, so how do I know it's 0? C out, arrow, arrow, quote, value equals, end quote, value, ENDL. All right. So, why did that become 0? Because when you have operators of the same priority, multiplication and division, or addition and subtraction, they're just done left to right. So these two are of the same priority, the same precedence, so it's just going to solve it left to right. And 1 divided by 2 is 0, because they're both n's. And so no matter what we had past that point. Could you get it to work? Yeah, you could do the 10 first, and then you could divide by 2 at the end. It's still going to be integer division, but how do you fix that? You make it 1.0, or you use some kind of casting to get it to work.
So if you wanted to multiply by a negative number, would you need to put that in parentheses, or could you just run it over like 2 times negative 3?
Yeah, you can just put it all the way across. And it's interesting that you asked that, because in really old versions of C, that wouldn't work, and you actually had to put negative numbers inside the parentheses. I don't know why when I was typing this, I accidentally wound up with the parentheses around it. But if I wanted to do value is equal to 1.0 divided by 2 times negative 3, this is called the unary operator, and it's higher precedence than anything else. So that immediately flips it to the negative number before the rest of the math happens. I'm going to undo that 0.0, and I'm going to add a comment that this gives 0 rather than negative 1.5. Why? The 1 divided by 2 equals 0. All right, gang, I think we've gone just about enough for today. There's a homework assignment. It's really no more difficult than the last homework assignment. It's just more of the same. Doesn't mean it's not worth doing. So let's go take a peek at it. This is last semester. That's why I'm not finding what I'm looking for. All right. Alright, so using the same techniques that we used in class and we used on our last homework. Write a program that asks the user for their weight in pounds and then display their weights in kilograms. I don't think that we did kilograms to pounds in our last conversion. The conversion formula is that. Now, is that exact? No. If you feel like using the exact conversion, you could find out, formula pounds to kilograms. And there's our exact. I don't see any need to make it any more precise than just saying 2.2. Alrighty, and then do a couple more tasks. And these can all just be in the same program, of course. Ask the user how many cows they have and display how many pigs they could trade for if 1 cow is equal to 3.5 pigs. So your equation is going to be pigs equals cow, and you have to figure out whether it's times 3.5 or divided by 3.5. If you get stuck on that, you can ask. Task. Ask the user how much money they have and display how many hamburgers they can buy if each burger costs $2.99. The formula is burgers is equal to money divided by 2.99. Lastly, ask for the user for the radius of a circle. We didn't do a circle in the last one, did we? Calculate the area and the circumference of the circle. Google the formulas or shoot me a message. It's pi r squared and 2 pi r. All right, I'll make a Dropbox for that. We're leaving a little bit early, so if you have questions over homework, we can hang out and talk about it instead of just rushing out the door. Let me make a Dropbox for today's in-class, so we'll have in-class C. right, any questions, gang? All righty. Well, I'll see y'all on Wednesday. Please feel free to text me if you get stuck on anything.